everyone, and welcome to this lesson about charging and static electricity. So there's different kinds of charges that we need to know about. There's positive charges, which is like that. There's negative charges, which has more electrons than protons. And in positive charges, there's more protons than electrons. And in neutral charges, where there are the same amount of protons and electrons. So now you might be wondering, how do objects even become charged? So basically, for objects to become charged, electrons have to move from one object to another. So let's say we have two objects here. Um, just add some protons and electrons. So first, these objects have to touch. So just like this. And once they touch, the electrons will get transferred to the other object. And then after that, when they stop touching, the charges will be changed for both of them. So basically, the main idea here is that for objects to become charged, the electrons have to move. Now, there's three cases of charging that you'll have to know. So the first case is charging by friction, when object one is neutral and object two is also neutral. And after that, the two objects will basically touch each other, and then object one will become charged, and object two will also become charged. So the next method is charging by contact. So at the start, object one is charged, so there's like might be more electrons and protons, and object two will be neutral. There's the same amount of electrons and protons. And here, for this one, I meant electrons and protons, not neutrons. So for charging by contact, the order doesn't matter. Object one could be neutral and object two could be charged. So for this case, they also transfer electrons by touching. And in the end, both the objects either have the same or the different charge as object one. So now the last case is charging by induction. So at the start, object one will be charged, and object two is usually neutral. But in this case, both the objects can be charged, so it's not necessary that object two has to be neutral. So for this case, they don't touch, unlike the other ones. And because they don't touch, no electrons actually get transferred. There's only like a temporary change in the charge. So in the end, object one will be, it'll be the same as the start. So object one will be charged and object two will be neutral. But now you might be wondering, how do electrons even get transferred? How do you decide the objects? And that's where the triboelectric series comes in place. And just make a note for yourselves, guys. The triboelectric series, it's only used for friction. Used for friction. You guys have to remember that. You can't use the triboelectric series for anything else. So basically what happens here, it basically shows the charge's tendency. So the higher the material is, the weaker the tendency is to gain electrons, and the lower it is on the chart, it has a stronger tendency to gain electrons. So let's go over some examples. Here, example one, when wool socks are rubbed with a cotton t-shirt. So here, wool is located right here, and cotton is located right here. So as we can see, wool is higher on the table than cotton, and cotton is lower. So that means cotton will gain the electrons. So that means the t-shirt will mm, gain electrons and will have a negative charge. A negative charge. And the socks will have a positive charge because they lose electrons. So now we have another case when a rubber balloon and human hair are rubbed. So let's find a rubber balloon and human hair on the chart. So at the very top here, we have almost at the very top, we have human hair and the rubber balloon we have nearly at the bottom. So since the rubber balloon is lower, that means the rubber balloon will be gaining the electrons. So the rubber balloon gains electrons, uh gained electrons and became um charged. And the human hair became positively charged. So now I'll go over some laws of the electric charges. So like charges repel each other, while so we can see here with both positives and negatives, they both repel each other. I mean, two positives repel each other and two negatives repel each other. Um, Opposite charges attract each other, so these will go towards each other, while charged and neutral objects will also attract each other. And lastly, we have Coulomb's law. So Coulomb's law states that the closer the objects, the stronger the electric force. So basically, as we can see here, these two objects, they're much closer together. So that means their electric force would be stronger. While these objects which are farther, their electric force would be weaker. Okay, so that's it for this lesson. Thank you guys for watching.